So today I want to give a little bit of an update on what's been going on with ZIO Test. So we've been spending a lot of time on ZIO 2.0. And as I think about it, the key ideas of ZIO 2.0 is really, one, celebrate some of the successes that we've had to date, both ZIO directly as well as the broader ecosystem. And I think people who got a chance to attend ZIO World the other week saw a lot of that. Just in the presentation we heard right now from Itamar, we again saw both a lot of things that have been built and how those things fit together, but also really hear and respond to feedback that we get from users of both things that are working for them as well as things that are not. And not just say, well, this is the way things are supposed to be, but say, okay, great, this isn't working for you. What can we do to make this better? And then build on that feedback as well as ideas we have and keep improving for the future. And we've really tried to take some of the same ideas and apply them to ZIO Test. So to start off, and this is probably going to be a review for some people who are already using ZIO Test and maybe an introduction for others who haven't got a chance to use it yet. But what are some of the successes? Why is ZIO Test awesome to use today? And why have people been having a really good experience using it to test their ZIO programs? Well, I think the first thing is this idea of tests as effects. So I see in a lot of different code bases, whether people are using ZIO or Monix or another effect system, unsafe run to future all the time. Unsafe run this, unsafe run this, unsafe run this, of essentially every time you've got a test, you've got to unsafely run whatever it is you're testing because your test framework doesn't know anything about effects. It knows about values like integers and Booleans, and maybe best case, it knows about futures, but it doesn't know about ZIO effects. And so you've got to kind of run those back to futures. And when you do that, you lose a lot of power. You lose kind of all this composability and all these nice functions we have on ZIO. You add a lot of noise to your tests, and you can also introduce subtle bugs. You can have situations where your test actually isn't running at all because you kind of described the effect, but you didn't run it. Where you kind of have like you're running one thing in another thing, and you can create deadlocks. There are like a lot of things that can go wrong there. So just being able to have a test framework that knows about effects and essentially just lets you be able to test effects and not have to do anything else with them is really nice here, where here we've got some stream of values and we want to test that at least the first 5 values meet some expectation. And we don't have to do anything special here. This is a ZIO stream. We're calling runCollect on it to actually get a set of values, and then we're making an assertion about them. And we didn't have to do anything separate for that. That just worked for us. And really the only thing we had to do to change from a test that works with normal values to a test that works with ZIO values is add this little M at the end of our test here. So I think that's been really nice. I think people really enjoy that. Another thing that's been, I think, really appreciated about ZIO Test is this way to safely manage resources within tests. So I think with other testing frameworks, a lot of times you have this idea of fixtures and you have your kind of before all and after all and before and after, and it kind of works, but one, it's a lot of times it's like not that composable where, okay, if you want to do something after all of your tests, it's okay. And if you want to do something just before this one test, it's okay. But if you want to do anything in between, if you kind of want to do around this group of tests like that, a lot of times like doesn't work as well. And it also typically doesn't fit in with potentially asynchronous effects and all the capabilities that we've been building. We talked about having this concept of a Z managed and being able to have managed resources that automatically get closed for us. And other testing frameworks, they don't know anything about that. Versus because ZIO Test built on ZIO, we know all about that. And so if you have a Kafka layer, that is this layer that describes your Kafka service, you can provide it to your tests, and you can either provide it to one test or you can provide it to a whole suite of tests. And if you use this shared variant of that operator, this layer is going to get acquired once. you're going to have access to it in all of the tests within the suite, and then it's guaranteed to be released at the end of your tests. And you can provide that to the whole suite. You can provide it to an individual test. You can provide it to a suite that's within a suite. So it's both a solution as well as a very composable and principled solution that builds up at any level you want it to. And it fits in with everything else you're doing with ZIO Test, where if you want to interrupt this, you still get that guarantee that that thing is going to be safely released. Another really nice feature of ZIO Test today is these test aspects. And so this was really one of the first places that we saw this aspect pattern that Itamar was also getting at. And so each of these aspects modifies something about how a test gets executed here. So you can imagine we're testing some concurrent code, and as we've been going through, most of the time our tests pass, but it seems like every now and then, maybe when we do the integration test versus the unit test, like this test seems to fail. And we're trying to figure out what's going on there. Well, all we have to do is we can stick this non-flaky operator on it, and that's going to run this test by default 100 different times to make sure that that test is actually stable. And if we want to, we can put a parameter here and we could run it 1,000 or 100,000 different times. And so that's a really nice, easy way to diagnose things like concurrency bugs and kind of make sure our code really works without actually having to change any of the execution of our tests. So we have that idea of we want to handle these concerns separately from the concerns of what we're actually testing. And there are lots of these aspects of different things. So you'd use one that times out a test after a given duration. And because all of these things are ZIO effects, we also have safe interruption. So if you actually time this thing out, it's actually going to interrupt this effect and stop whatever fiber is working there. Versus in a lot of other test frameworks, if they say they're timing something out, all they're really doing is failing this test, but whatever is running in here may still be running and using a bunch of resources and creating a memory leak. And then you can also even control like whether test runs at all on different platforms, different Scala versions. So you could say, well, this concurrency test, maybe I support Scala.js, but Scala.js actually isn't doing the same level type of concurrency. This test only makes sense to run on a JVM. And all these things you can just chain together like this. So I think is one of the things I hear most often from people about like, wow, I love this. This really helps me out. And I personally find it's a really nice feature. Like when I've been developing different like concurrent data structures, things like that, this is like really nice to make sure that what you're doing is actually working. And then another thing that's been nice with ZIO Test is these test services. So these are implementations, test implementations of each of the default services that ZIO provides. So the clock that controls time and delaying actions, the random service that lets you generate random numbers or other types of random data, things like that. And each one of these is comes with a bunch of functionality that makes it very easy to test effects that involve that type of service. So for example, one of these is this test clock, which lets you test effects involving the passage of time. And so here let's say we've implemented some type of timeout operator that is supposed to time out this effect if it takes more than this amount of time. And we want to actually make sure this works correctly. But we want to do that without waiting 1 minute or 5 minutes or any time, because we may want to run this test with that non-flaky operator 100 or 1,000 different times. And we want this all to go really fast. And so it's really easy to do that, where all we do is we take that same effect that we wanted to test, we fork it into its own fiber, and then we call this test clock adjust method. And that will run everything that's scheduled to run up to that time in the order that it would otherwise run if real time was passing. So when we do this timeout's going to execute, and assume this is working correctly, that's going to then time out this delay here, and we're going to get a none. So really nice for testing this kind of code that can be hard to test otherwise. And then finally, the built-in support for property-based testing is really nice. So generators and property-based testing is built in out of the box, and you essentially write property-based tests the same way that you would write any other test. So here, let's say we've got some type of event. We've got a generative events, and we just want to test that when we encode an event and then decode an event, we get back the same event. And you can imagine if we didn't have a generator, if we just made up one event of our own, this test would look basically the same with this line unchanged, and we'd just have some val event equals whatever the event is. And we want to move to property-based testing. All we do is we substitute a check operator here, which is the ZIO Test's operator that says, okay, I want to do a property-based test instead of actually defining that, and then it just gives us those events. So it's very easy to substitute property-based tests for traditional tests, to mix and match them and do it all very seamlessly. So those are the good things about ZIO Test. I think that's what people have enjoyed about it, but I'm not just here to tell you, oh, it's so great for all these reasons. What are some of the things that we've heard that are not as great? So one pain point today is around shared resources. So we talked before about how you could share resources within a suite. So you could have a whole suite where around the suite, you create your Kafka service. At the beginning of that, you get to execute all your tests using that one Kafka service. And then at the end of that, you get your guarantee that that service is going to be shut down. And that's great. And you can definitely use that and put all your Kafka tests into that one suite and that one file. But what we found is that for larger organizations, they often need some of these resources across a whole bunch of specs that are spread across a whole bunch of different files. Of that, you want that Kafka service to be open, and then you want to do 10 different tests that are maybe in different modules, different files, and you want to have access ideally to that same Kafka service in all of those tests. And right now you can do it, but it involves a little bit of boilerplate where basically you've got to kind of create like a new spec and then make all the other ones a part of that. And it's not as nice as we'd like it to be. So that's one thing that you could say, okay, that's an opportunity for improvement. Another one is assertions. So you've probably seen in a couple of the other examples that we have these assertions. And in a way, they're really nice. They essentially let you zero in on a value that you want to make an assertion about and make very specific claims about what you expect to be true of it. So you can imagine here, we're getting some values, maybe we've gotten them out of a queue, and we want to say, okay, these values have a given length, and that length is equal to this value, and they also are sorted. And you can see how you might substitute these of maybe we don't actually want to say the length is equal to this. Maybe we want to say the length is equal to or greater than or less than. The nice thing about this is it's very composable, and it gives you these nice error messages of if this thing is not satisfied, even though this is, you'll get nice highlighting of what went wrong here. So that's all great. But I think the flip side of this that we've heard from our users is you kind of need to remember or look up what these different assertions are. So in a way, these assertions were like our answer to some of those like matcher syntax of like the should be. And I always thought that was kind of a very unpleasant to use because you just like had to learn this whole new DSL and all you want to do is write your tests. It wasn't like it was solving some massive problem for you. And in a way, this is a lot better of that they're all just methods in one place. They're not implicit. You can just look them up, but you still have to spend some time learning or looking up what these are. And a lot of times you just want to assert that something is equal to what you expect it to be. And you just kind of want to get on with running your tests. And yeah, sure, we could do this and have like very precise statements of what we want, but really we just want to say it's equal to this thing and we want to move on and do other things with our day. And then I think the third area for improvement that we've definitely heard about is this, just the ergonomics of writing the specs. And sorry that this is a typo here, this should just be default runnable spec. But the way you typically write a spec today is you define a suite that's going to be the suite for the whole spec. So here, if we had an object my spec, you typically call this suite my spec. and then you'd have a set of suites within that, and then they could have tests or suites within those. And in a way, this is totally fine. In a way, it's very nice if you can have this hierarchical structure at whatever level you want. But there are also a couple of like things that are a little bit annoying here. You notice, for example, we have this comma here because this whole thing is actually implemented as this suite as a method that's taking a variable number of arguments here. So Scal, if you have a variable number of arguments you're passing to a function, each of them has to have a parentheses between it because each of them is one of the things you're passing to the function. So if you forget this comma here, you're going to get a compilation error. Another thing that's a little bit less than ideal is you have to have this like extra suite here of, in a way, you'd think, hey, I already defined the object as my spec. I shouldn't have to have another suite here. I should be able to kind of reduce all this nesting by one level and push that to the left here. And then sometimes you also have to be a little bit careful about where you have like parentheses versus brackets here, because again, all these things are implemented as variable number of arguments. So those are some areas where definitely none of them showstoppers, but areas where we heard like, hey, things could be a little bit nicer here. So what are we doing about them? Well, the first one, we're introducing a, right now we're calling it a custom runnable spec. They may change slightly, but this is a spec that allows you to define a layer that produces some environment that you need. So this says, hey, I need this thing and here's how you can make it. I need this Kafka service, here's how you can make it. And when the test framework actually goes to run all the tests, it'll grab all of those layers from every one of these specs, it'll put them all together, and it'll see when it has the same layer. So if you've got 10 different specs that all said, hey, I need a Kafka service layer, it's going to take all those and it's going to build that layer once, and then it's going to provide those to each of those specs. So that way you can have a solution to that problem. If you wanted that Kafka service set up, you wanted to use it in 10 different files, and you only wanted to build it once. This will do that for you. The second thing is assertions. So we're introducing a new, you call it super assertion, that is going to subsume a lot of the functionality that you typically get from those more detailed assertions today. So the idea is that if you should never really have to use any of those other assertions. If for some reason you want to, okay, great. But the way you can just easily do assertions for any of your tests is with this one assertion operator. Right now we're calling assert_equal. It may actually be further simplified. We may be able to just move to just asserting and this just being one function that returns a Boolean value. But basically what this does is this is powered by a macro. And if you've been using ZIO Test, you may have seen some of this functionality already in some of the better error messages that you've gotten in some of the recent versions, where you actually get like the line number of the failure and you get some additional information about that. And so this will just grab this left-hand side and it'll grab that from the actual expression there. And it'll tell you what that expression was, what it evaluated to, and then that it didn't equal your expected value here. And so the idea is really most of the time, like, okay, we can do these super detailed assertions, but most of the time we either just want to assert that's equal to something, or we can end up doing a bunch of things ourselves. So you can imagine maybe in the previous incarnation, this would have been option 3, and then this would have been like is sum equal to 3, but we can kind of replace all that is sum equal to and just say that value. So our goal here is we want to make it a lot more simple to write tests of, if you don't want to look up any of these assertions, if you don't want to deal with that, if you just want to write your tests, this is here for you. You can get on a very minimal way of writing your tests, get all these other useful features from ZIO Test, and still get very helpful error messages for these assertions. And then the final thing is this concept of a mutable runnable spec here. And so this, I think some people may have actually used this, because this is been around for a little while as we've been building this out, but this is a simpler variant of a spec where each of these is it's essentially just a builder pattern where each of these suite calls here is just gonna take this thing and add it to the master spec here. And so you can see we got rid of the concept of having to have that like extra layer of suite here because by default, this is all just going to be constructed within one suite that has the name of this master of this spec here. So we'll just have one my spec suite. And then we got rid of those commas. We were able to standardize the braces here a little bit. So it's something where I think for some people, it probably doesn't matter if they were kind of used to the old way of doing it and it was fine. I think for some people, some of the commas and stuff were super annoying. So our goal is really that there should be no reason that you shouldn't use ZIO Test. That it should be totally painless for you, however you want to do it, for you to test your ZIO programs. So I definitely, I guess we got 3 of us, so it's probably a good thing that I'm a little shorter, but that's a little bit of what we've got in store for you with ZIO Test coming up. Our goal is really that we want this to be the go-to testing framework for ZIO programs and to make it very easy for you to test anything you'd want to about ZIO programs. And it's really feedback from users that's helped us make these improvements, that's helped us add a ton of other features over time. So we really appreciate hearing from people about what's working, what's not, what's annoying, what's missing, and we just want to keep incorporating that and getting better. I really encourage, if you haven't used it, to try it out. If you're doing anything, especially with ZIOFX, but even all this functionality works even if your program isn't using ZIOFX. So if you're doing other things, you still get all that property-based testing, all these test aspects, all of this stuff. So I would really encourage you to check it out. And finally, just thank you. So John is coming up next, and I guess I'll give him more of an introduction then. But he had the original idea for this library and has been constantly making sure we're on the straight and narrow as we've been working on that, as well as being a personal mentor to me. All of the other ZIO contributors, all the users who've given feedback, and then particularly want to give a call out to 2 of my other colleagues at Zyverge who've done work on 2 of these features. So Ablash, who did work on the shared resources feature, and then Franciszek, who did work on the ergonomics of that MutableRunnableSpec you had. So I've included their GitHub handles, and I think they're the same ones on Discord. So I would encourage everyone to give them a shout out for their work on this and to generally say hi to them. And I have a feeling you're going to be seeing more stuff from them in the future. But with that, I will hand it over here.